If you're building with LLMs, you know the feeling. The model just gets it wrong. Today, we're going to break down one of the most fundamental patterns in prompt engineering, chain of thought. But look, this isn't just theory. We're going to treat it for what it really is, a core engineering trade-off you absolutely need to master.
Okay, let's jump right in with a kind of weird question. What if you had a computer that had no internal monologue? No scratchpad, no way to quietly work through a problem before spitting out an answer. That sounds like a massive limitation, right? Well, that is the exact world a large language model lives in, every single day.
And this right here is the fundamental constraint you have to wrap your head around. An LLM doesn't have a separate thinking process happening in the background. The only way it can process information, the only way it can reason from one step to the next is by generating text, one token at a time. Its thought process is its output.
Let's make this super real. I want you to try something with me right now. Multiply 349 by 921. In your head, go on, try it, no pen, no paper. It's basically impossible, isn't it? You'd probably just take a wild guess. And yet, that is exactly what we ask an LLM to do in a single forward pass. We throw a complex problem at it and expect a perfect, instant answer.
This default method, where we just ask the question directly, has a name. It's called zero-shot prompting. It's the fastest, it's the cheapest way to get a response, but like we just saw with our little math problem, when the logic gets even a little bit tricky, the model is essentially forced to make an intuitive leap. It's just guessing.
And that really is the heart of the problem, isn't it? For anything more than just grabbing a simple fact, for any kind of multi-step reasoning, you need a place to show your work. You need a scratchpad.
So the big question is, how do we give the model a scratchpad that it doesn't naturally have? Well, we make one for it. And this is where we get into a core engineering decision, what I call the token for accuracy trade. We're going to deliberately choose to spend more tokens, more compute, to get a much more reliable result.
The solution here is almost, it's deceptively simple. It's not some crazy new algorithm. We literally just tell the model, think step by step. That's it. By forcing it to generate those intermediate steps, step 1, step 2, step 3, we are creating that scratchpad out of thin air.
So how does this actually work under the hood? It's all about the context window. First, you prompt the model to break down the problem. So it generates step 1, calculate the fair difference. Now here's the magic trick. That sentence it just generated is immediately fed back in as part of its own context for the next step. So when it goes to generate step 2, it's not just seeing the original problem, it's seeing the original problem plus its own conclusion from step 1. It's building on its own work, token by token, creating a literal chain of thought.
Now there's no free lunch here. This comes at a cost. More steps mean more tokens. More tokens mean higher latency for your user and a bigger bill from your API provider. You are consciously paying what I like to call a token tax to buy yourself accuracy and, just as important for production systems, reliability. Okay, theory is great, but let's see where the rubber meets the road. We're going to run a full-on failure analysis on a real-world scenario. Let's imagine a company, Skystream Airlines, and see what happens when we don't pay that token tax.
All right, here's the setup. We have a gold status customer. They want to change their old $200 ticket to a new, more expensive $350 ticket. There's a standard $50 change fee, but their gold status gets them a 50% discount on that fee. Seems simple enough for a person, right? But for an LLM trying to do this all in one shot, it's a perfect storm for failure.
And here's what happens. The user asks the zero-shot model, how much do I owe? The model rushes, it does the easy math, $350 minus $200, and it confidently says $150. It completely forgot about the change fee, the discount, all of it. Why? Because it tried to leap straight to an answer. Now look at the chain of thought approach. We forced it to show its work. Step 1, fair difference is $150. Check. Step 2, base change fee is $50. Check. Step 3, apply the 50% discount so the fee is now $25. Check. Step 4, add them up. Total due, $175. Perfect. And it's completely transparent.
This example gives us a really powerful mental model you can take with you when you're designing your own systems. I like to call it the leap versus the staircase.
On one side, you've got zero shot. It's a leap of faith across a canyon. You're asking the model to jump from a complex problem straight to the answer. It's fast, sure, but as you can see, it often ends up falling into a messy, unpredictable hallucination. On the other side, you have chain of thought. It's a staircase. Yeah, it's slower. You have to take it one step at a time. But every single step is solid, it's transparent, and it leads you predictably and safely to the right answer every time. And that right there
is the key takeaway for any production system. Chain of thought isn't just about getting the right answer. It's about turning a black box computation into a white box. It creates a visible, auditable trail of logic. So when something goes wrong, and it will, you don't have to guess why. You can literally read the model's mind and see exactly where its reasoning went off the rails.
So, we've done it. We've given our model a scratchpad, we've taught it how to reason, and we've made our systems way more reliable. But we've only really solved half the problem. What happens when the underlying facts change? What if Skystream Airlines changed its fee policy this morning? The model's reasoning might be perfect, but its knowledge of the world is totally stale. And that, well, that sets us up perfectly for our next explainer.